Right, this is starting chapter 9. We're going to be talking about probability in chapter 9, which is, I always thought was just kind of fun to think of the probabilities of things and to understand what people are talking about when they give you odds for winning or losing a game. Before we start, we're going to start with a couple of vocabulary terms. The first one is experiment. Now, this is going to be different from a science experiment. In a science experiment, you're looking for answering a question. In a probability experiment, that's going to be the activity that is observed. So let's say that's drawing a card out of a deck of cards, or rolling a dice, or flipping a coin. That would be the experiment. The trial is the observation of that experiment. So let's say we had 3 dice and we were wanting to roll them 3 times and find out what our outcome is. So experiment would be rolling the 3 dice. Our trial would be each observation, each time you roll the 3 dice. And then the outcome would be the results of the overall experiment. The next thing you need to know is sample space. So that's going to be the possible outcomes. So for example, if our experiment was flipping a coin, our sample space would be you either get heads or you get tails. You're not going to get anything other than those two. Or if you're rolling a dice, you could get a 1, 2, 3, 4, 5, or 6. All right, if it's a normal dice. Right, the next one is an event. That is going to be any set of one or more outcomes would be an event. And probability of an event happening is going to be from either 0% to 100%, or if we're talking about in decimals, because remember, from a percentage to a decimal, 100% would be a 1, and a 0% would be a 0, and then say 50%, that would be 0.5. All right, so anything in between 0 to 1 or 0% to 100% to tell you how likely that event is going to happen. So 0 probability means that the event is impossible, and a probability of 1 means that the event is absolutely certain. So if you have a 100% chance of rain, that means it's raining right at that moment. All right, so we're going to find the probabilities of outcomes in a sample space. Now remember, sample space are the outcomes that could happen. If we're talking about a weather forecast, you could have rain or you could not have rain. Those are going to be our possible outcomes. So we're going to find the probabilities of each of the outcomes in the sample space. Now, if the weather forecast is showing a 40% chance of rain, we're going to find the chance of rain and the not chance of rain. So probability, we are looking for it to be in decimal form. So we need to change our 40% to a decimal. So to go from 40%, whoops, I left out my 0. We're going to take our decimal, which would be right here, and we're going to move it right 2 spaces. So our probability of rain is going to be 0.4. Now, the probability of not rain, how do we find that? That's not in our information at all. Well, our probabilities need to be able to add up to a 1. So what we'll do to find our not rain is we take our 1 for our total probability, 100%. We'll subtract our 0.4 for the chance that we have, and what we are left with is 0.6. So the chances of not having rain are going to be 0.6 or 60%. Right? So just remember that your outcomes in your sample have to add up to a 100%. Given that, let's try the next one. So we have this spinner here where you move the little arrow, and we're wanting to find out what the probabilities are. Well, you can either get a red, or you can get a yellow, or you can get a blue. So by looking at the spinner, what is the chances of getting red? Well, there's 4 total things that it could land on, so it's going to be out of 4, and 2 of the 4 are red. So let's take that 2 out of 4 and make it a reduced ratio, which would be a 1/2. What's the probability of getting yellow? Well, it's 1 out of 4. What's our probability of getting blue? Also 1 out of 4. Let's just make sure that they add up. So if we have 2/4 plus 1/4 plus 1/4, 2 plus 1 plus 1 is 4. So that would be 4/4. That is equal to 1. So our probabilities work out nicely. Just making sure that they all add up is how you would check it. So the chances of getting a red are half, 50%. The chance of getting a yellow is 25%, and the chance of getting a blue would also be 25%. So how do we find the probabilities of the events? So let's say we have a quiz that has 5 multiple choice questions, and let's just say you don't have a clue and you guess randomly on every single question. So I'm going to give you a table that tells you how likely you are to get each score. So let's say a score of 0, your chances out of 5 of getting a 0 are about 23%. Of getting at least 1 right would be about 40%. Of getting 2 right is going to drop back down to 26%. Of getting 3 right, so the more you're getting right, especially if you're guessing on every one, your chances of getting that many right are going to go down and down and down. So this would be a 9%, a 1%, and a 0.1% of making 100 on a quiz that you don't have a clue what any of the answers are to. So let's answer some questions about our events. So what is the probability of guessing 1 or more correct? So we're going to look at our scores. If you score a 0, did you guess 1 correct? No. If you score a 1, you're guessing 1 correct. If you scored a 2, you got at least 1 correct. 3, 4, and 5. So to find the probability of guessing 1 or more correct, which would be an event, we're going to add up our probabilities of anything that could fall into that. Because if you got them all correct, then you guessed at least 1 correct. If you got 4 correct, you guessed at least 1 correct. I hope that you can see why we are choosing 1, 2, 3, 4, or 5. So we're just going to add those up. So I'm going to take my 0.396 plus my 0.264 plus my 0.088 plus my 0.014 plus my 0.001. When I put those in and I add all of those up, I'm going to get about 0.763. And we can turn that into a percentage by saying 76%. So the chances of getting at least 1 correct are 76%. What's the probability of guessing less than 2 correct? All right. So less than 2 means that you don't get more than 2 correct, right? So we're not going to use this one. This one's not missing 2. This one's getting fewer than 2. That one, it would also be less than 2 correct. So if you're going to get less than 2 correct, you only got 1 right or you got 0 right. So we're going to add those 2 up. So I'll do my 0.237 plus my 0.396. We add those up, that would be 0.633 or 63%. So the chances of getting less than 2 right would be 63%. Pretty good probability. What is the probability of passing the quiz? So passing the quiz would be getting either 4 or 5 correct, because 4 out of 5 would be a passing and a 5 out of 5 would be 100. So what's the probability of passing altogether? We're only going to be looking at these 2, because if you get only 3 right, you don't pass. So I would add those 2 up. So 0.014 plus 0.001. That is going to give me 0.015 or 1.5%. So the chances of passing a quiz, if you don't study for it at all, are a 1.5% chance of passing. Those are pretty low chances of passing. So it's a really good idea to go ahead and be studying for quizzes, right? Go ahead and click on the link and do the homework, and I will see you in class. Have a good evening.